So now we're going to be graphing lines given a point and the slope. And we do not need to find the equation before we can graph the line. In fact, first we're going to graph the line, and then we're going to write the equation of the line. We might be able to figure out the equation in slope-intercept form once the line is graphed, or we might need to use point-slope to help us write the equation. Let's look at this first one. Graph a line with a slope of 4 that passes through the point -4, 2. So that's going to, our first step is going to be to graph that point. So this is really no different than graphing a line in slope-intercept form, where you graph the y-intercept, except instead of graphing the y-intercept, you're just going to graph whatever point you're given. So we're given the point -4, 2, so we're going to graph that point. And then you're going to use the slope to count out more points. So it's just like you saw on the previous video, except instead of the point being the y-intercept, it's some other point. All right, so the slope of this line, so first of all, slope is rise over run. And there's two ways we could consider this slope. So the slope is -4. So we could think of the rise as -4 and the run as 1. Or we could think of the rise as 4 and the slope as -1. One of those values has to be negative. If we want to count to the right, we'll want the first one. So -4 means we're going to count down 4 and to the right 1. And if our point is way over on the right-hand side, we might want to count to the left. Right? So we can use 4, -1, which means that we're going to count up 4 and to the left, -1, left 1. So we're actually going to do both of these things because I do have enough space to go a little more to the left if I move this point. And I have lots of space to go to the right. All right, so first let's do 4, -1, which means we're going to count up 4, 1, 2, 3, 4, and to the left 1. And you'll be able to see in a moment that that point is on the same line as all of the other points. It's just to the left as opposed to the right. Now we have no more space to go to the left, so let's graph all the points we can to the right, which means we're going to count down 4, 1, 2, 3, 4, and to the right 1. And down 4, 1, 2, 3, 4, to the right 1. And we are out of space. So now let's graph the line. I'm going to use a line tool just because, whoops, it'll be a straighter line. And then it decided to glitch out on me. All right, and I'll straighten that up a little bit. All right, that looks good. All right, so there is, we have now graphed the line that has a slope of -4, and it passes through the point -4, 2. And if we wanted to write the equation by looking at the graph in slope-intercept form, we would have some trouble because you see the graph is not crossing the y-axis. It will eventually cross the y-axis, it just doesn't do it in the part of the graph we can see. So to write the equation of the line, we're going to use point-slope form. As a reminder, that is y minus y1 equals m times x minus x1. And of course the m is the slope. And x1, y1 is the point we're given. So we have y minus 2 equals -4 times x minus a -4. Right, so let's simplify that double negative. So y minus 2 equals negative 4 times x plus 4. Two negatives make a plus. And now we're going to distribute. So I'm going to move over here. And actually, as the equation is written, this is point-slope form. Right? That is point-slope. It is all finished. But we're also going to put the equation into slope-intercept form. So to do that, we're going to distribute that 4 to the x and the 4. So we have y minus 2 equals negative 4x minus 16. And in the last step, we'll add 2 to both sides. So in slope-intercept form, the equation of the line is y equals negative 4x minus 14. Right, so this would be slope-intercept form. And you can see why we can't see the y-intercept on the graph. It's all the way at negative 14, and this graph only goes, well, technically it goes to negative 7. The very last line on the graph would be negative 7. So we still have 7 more spaces to go down. And there we go. There's our first one done. This one is not in your notes. Oh, I'm going to sneeze. Oops. But the next one is, I just want to move I have a recording box here, and I like to keep track of how long my videos are. And it's off to the side. Now I can see it. You can't see it, but I can see it. All right, oops, I thought I had erased this. All right, we're going to erase it really quickly. Because I want to go over this problem with you. There we go. All gone. All right, so again, we're going to graph the equation given the slope and a point. And that point is not the y-intercept, but all of the points on the line, and all the points that are satisfy the equation are going to be on the line. So we could graph any point we want. In this case, we're going to graph the point negative 6, negative 4. So 1, 2, 3, 4, right here. As a reminder, the slope is rise over run. And we have a positive slope, which means that either both the rise and the run are positive, which means we'll count up and to the right. Or they're both negative. And we're going to count down and to the left. Now in this case, our point is so far to the left, there is no room to the left and down. There is just no room to count any further to the left. We have counted to the left all we can. We can't. So we will not be counting down and to the left, just up and to the right. So from the point negative 6, 4, we're going to count up 1, to the right 2, 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 and I can do that one more time. And there we go. Let's go ahead, and I'm going to use that line tool to graph, and you might want to use a ruler so you can graph a straight line. And this line will keep on going, so I'm going to put arrows. Now this could be just ever so slightly better. There we go, that's pretty good. And we're going to write the equation of the line. So we have graphed the line. We started off by graphing the point, negative 6, negative 4. And then we used the slope to count out as many points as we could. Now in this case, we could write the equation of the line from the graph. We can do that because we literally counted and landed right on the y-intercept. So if you count and land on the y-axis, then you can simply write the equation of your line in slope-intercept form. And so that's one of the reasons why you want to wait to write the equation of the line. Graph it first. Use the point you're given, use the slope, graph it, and then write the equation of the line, because sometimes you'll be able to just write it in slope-intercept form. So the equation from the graph, we can see that the y-intercept is 0, -1. So the format in slope-intercept form is y equals mx plus b. M is the slope, and b is the y-intercept, where it crosses the y-axis. So y equals 1/2 x minus 1 is the equation for the line in slope-intercept form. Easy peasy. However, you're not always going to be able to see what the y-intercept is from the graph. It could be, like on the last example, the y-intercept is not even on the part of the graph we graphed. It could be that it's not an integer value, that we had to count over the y-axis when we were counting out the points. And you'll actually find that on the practice problems that are after this video. So for practice, since this is the only one in your notes, let's also use point-slope form, and we'll see if we actually do get the exact same equation. So point-slope form will be y minus y1 equals m times x minus x1. x1 and y1 is the point we're given. Use that one because you're sure of that one, because you were told that point. And of course, 1/2 is the slope. So let's go ahead and plug our values in. So we have y minus a -4 equals 1/2 times x minus a -6. Let's simplify the double negatives. So y minus a -4 is y plus 4. Minus a -6 is x plus 6. We can go ahead and so right now it is in point-slope form. So that is point-slope form as soon as we simplify those double negatives. Let's go ahead and distribute the 1/2 because we're going to rewrite it in slope-intercept form. So y plus 4 equals 1/2 times x is 1/2 x, and half of 6 is 3. Right? If you have 6 cookies and you eat half of them, you ate 3. Our last step is to subtract 4, and we have y equals 1/2 x minus 1. So you can see that we got the exact same equation from the graph, and then over this one, right, using point slope. So using the graph or using, I'll abbreviate, point slope, we get the exact same equation. So it doesn't matter how you write your equation, except sometimes you're not going to be able to go directly into slope-intercept form based on the information you have in the graph. So that's the end of this video. Go ahead and do the practice problems. There are 2 where you're just graphing in slope-intercept form. You graph the y-intercept, you count using the slope. There's 2 problems like the ones in the previous video where you will have to simplify the equation first into slope-intercept form, like this one here, right, where you may have to do some operations to isolate y. And then there are 2 like the ones we just did in this video, and for those you'll graph the point, you'll use the slope to count out more points and graph the line, and then you will need to use point-slope form to write the equation of the line. One of them will be off the graph, and one will not be an integer. The one y-intercept will be off the graph, and one y-intercept will not be an integer. So thanks for watching, and bye for now.